Hi everybody, and welcome to this video about reverse engineering of MBR Wiper. If you check my Twitter, I basically shared a tweet about analysis of MBR Wiper, which is written in Delphi, and also analysis about the infected Bootstrap code, which basically will be injected to the original MBR. And if you check the screenshots, there is the output of the decompiled view from IDAPro, and I shared some steps necessary to do in IDA to get this kind of output, which is, I hope, quite nice. But I think it could be quite nice if I share also video record how you can do this on your own to learn something, hopefully, and enjoy it. Basically, also you can see that I used interactive Delphi reconstructor, and I will show you why. I also shared some tips why I use that, but I hope that I will quite make it clear when I will be covering this in a video. And also we will be analyzing the Bootstrap code, and we will be using the Bochs emulator in IDA. You can see download. You can download all these things. The annotated IDA database from my GitHub page, and also the sample. The original sample is also in the archive on the GitHub. You can download it, and I will show you what you received. And that's probably all. The link to the GitHub will be also included below this video, so you can check it and do it on your own. So let's jump to VM. Okay, so after you download the archive, you just unzip it, and the password is, as always, infected. You can see here that there is already the IDA database, which is annotated, and it could serve you as a little hint for you if you will be analyzing on your own. But we'll be using this sample and do it again from the start. There are also the screenshots you can saw on my Twitter, and also prepare the Bochs image for you to analyze the Bootstrap, the infected Bootstrap code. So first of all, we have here the original sample. If you check the hash of the sample, you can see that it's already quite nicely detected, but from the start there was like 6 or 4 detections, so not very good, but now it's well detected as I kill MBR or MBR Wiper. So basically these steps are very common whenever you are dealing, whatever you are dealing, because first of all we have to make sure that this is really executable file, Windows executable, for what architecture, and it in what language it's written, in what language it's compiled. So first of all, I will check it in hex editor, because it's one of the most reliable thing, and you can see the mzip header, and it looks really like an executable file. Nice. So another thing what I will be doing is basically using my very favorite tool called Detect It Easy. If you check the Detect It Easy, it will also already tell you that, yeah, the program is probably compiled in Delphi, Borland Delphi 6 or 7. This is very important, because we will need this information, and we will benefit from this information. You can see it's 32-bit executable and compiled in Delphi, Borland Delphi 6 or 7. Nice. You can see that the timestamp is probably spoofed, surely. And yeah, that's basically what we need. You can also see that there are more scans engines. You can see also nose file detector, and it will also tell you that it's a Borland Delphi. But we will need this version 6 or 7. Nice. You can also use other things like exe info, and other way it will tell you that it's again Borland Delphi 2 or 7, 2 to 7, but I think it's 6 or 7 Borland Delphi. If you want to make it sure, you can see the strings, and there should be some strings related to Borland Delphi. So if you check like Delphi string, you can see here is something related to Borland Delphi and other things. Yeah, again. If you check the strings, there is already something which is quite nice, some nodes, some noob nodes. Basically, these nodes will be written to the MBR, and not MBR, but to the disk, and the MBR Bootstrap code will read it and print it to the screen. I will show you later. And yeah, you can see also some quite interesting string custom MBR created by WobbyChip. WobbyChip is not some kind of malware actor or threat actor. WobbyChip is some kind of person which basically did some builder for MBR writers or MBR overwriters. And this builder is abused by some kind of skids or people which will try to create their own MBR Wiper overwriter. So it's just abused and not the malware actor itself. So yeah, this was quite nice. First of all, we can just throw it to IDA 32-bit. Okay. And you will see that basically IDA can recognize it as Delphi. So we will help it. We will help the IDA to recognize it correctly and other things. So yep, the analysis finished, and yep, we are on the entry point. We will be using another tool which is called Interactive Delphi Reconstructor, and I will run it now because it will tell you also another thing very important. It's basically a tool for Delphi, so it could also recognize the exe file correctly. So throw it, and you can see it's already recognized as Delphi 7. So it's probably Delphi 7. So detect it easy, nice job as always. And what you can see here are some already recognized functions. These function init exe, string to integer, and these are Windows API calls from imports, but there are many things related to Delphi functions here. You can imagine, or you can think about these functions like something. Whenever you are creating a exe file or program, you can statically import statically linked some libraries. And when you are dealing with Delphi, it's quite something similar to it, because this function will not be defaultly recognized in IDA. So I will try to show you how you can recognize that correctly. Okay, first of all, we are on the entry point, and you can see that first call is init exe. If you check it in IDA, you can see that first call is not recognized, and many other calls are not recognized. You can see 1, 2, 3. Other 3 functions. You can see that these functions are recognized in Interactive Delphi Reconstructor. Nice. So how you can do it in IDA? First of all, this is a Delphi program. Delphi program has different kind of calling convention than C compile programs and other things. So no cdecl, no standard call, but you can immediately see that how arguments are treated when they are going to function. Yeah, you can see that basically arguments are moved to registers. Yeah, for example, here is another one, and it's moved to register EAX. So EAX is some kind of EAX is a register which is in Delphi program used as for argument to functions. You can also see another functions here in the ending, and you can see that here is EDX and EAX. So this is something what is called registry calling convention, which surprise surprise is the same as Fastcall. So first of all, we will change the compiler option to set it to Delphi, and we will set the calling convention to Fastcall. So go to option, we can make it better like this, yeah. Go to options and compiler set it to Delphi, and calling convention set it to Fastcall. And okay, this is first step. Another step is that basically there are some strings related to Delphi, and Delphi is treating strings or working with strings quite differently. Like string literals are not defined like C, for example, that you have string ending with null termination, null by termination. It's something different, and you can see it here. These are strings. So if you unidentified it, you can see something like this. This is start of string. Basically, it's defined as a string length and string content. So if you will, for example, create a string here, it will not be able to create a string. Why? Because you didn't define that these are type of Delphi strings. So go back, or you can be here, it doesn't matter. Go to general, go to strings, and change default string literal type to Delphi. Yep, and that's it. Okay, and now press A, and you can see it's better. Yep, and the same for this and for other. I will do it later. Another thing what you have to do is basically you have to have the proper type libraries, which is also related to Delphi, and you have to apply FLIRT signature to successfully recognize function like interactive Delphi reconstructor. How you can do it? First of all, go to View, Open Subview, and select type libraries, and View, Open Subview, and select signatures. In type libraries, you can see here that we don't need NT-API, so you can unload that. And this one is for C, because it will tell you that it's for C. If you wanna load it again, MS SDK 32 Win7 here, you can try to load it. It will tell you, hey, this compiler is set to Delphi. Ignore it, because we will need some types from MS SDK Win7, because not every types are defined in the Borland Delphi for Windows. Yeah, but the library we need is also here, the Borland BCB 5 Windows, Borland CBR V5. This is basically Windows types for Borland. Press OK. Ignore. And that's it. Nice. We don't need type libraries anymore, and go to signatures. Apply new signatures, and try to find signatures which are related to BDS, like or Borland Delphi. So for example, you can see Delphi, and here are some nice things. So BDS, search for BDS, and I think that these three signatures should be applied. This one, apply new, BDS, and apply new, BDS. Okay, this should be enough. Now we successfully applied signatures, loaded the proper type libraries, and set the compiler to Borland Delphi, set the string literals to treat it as Delphi strings, which are defined with length and the string content, no null termination. But it's okay. Nice. Let's check it. If you check it here, now we have nicely, you can see it also from the start, we have nicely defined the function which were not recognized before. So what you can see here strange names, which is called mangled names. We can get rid of it quite easily. Go to options, demangled names, and show demangled names as names. Okay, and that's better in the assembly view. You can check the pseudocode, pseudo C, and it's already much better. Yeah, you can recognize many functions which are related to Borland Delphi and which were not previously recognized. Now we have set everything for our steps with analysis. I think that the interactive Delphi reconstructor is very useful because you can see many things here. For example, sometimes IDA can recognize that the Delphi function takes, for example, 3 arguments, and it thinks that it just takes 2 arguments. For example, there is something like string compare. You can see string compare, and also check the definition, yeah, or the prototype. You can see it thinks that there goes integer, and return value is integer. If you try to find the string compare, you can see it's in the system, so you can find it here quite nicely, or you can just scroll a little down and check it here. String compare. If you right click on it, you can immediately view prototype, and this is the prototype. You can see that arguments are string, and no return. Yep. Nice. If you just click on the system, you can see it here, and you can just find it here. String, and yeah, here is actually nice thing that the return value is basically input destination string. I think it's like this. ASCII destination, I think. Oh, it doesn't matter. We can just retype it. Just press Y, and we know that this should be some kind of string. String 1, and this should be some kind of string 2. But the count of the argument is correct. Okay. And return could be white. Yep, it's better. What is quite nice here, that we have recognized something here, because we treat it already as a string. But if you wanna do it for all of these things, you can unidentified we can unidentified all, and let's do it one more time. Here, and press, you can just right click and change it to a string, or just press A, and here the length A, here is another one A, and here is another one A, and these are defined as strings, Delphi strings, length and the string value. Nice. And you can see here it's basically the same is here, just unidentified, and just create a string from it. Press A, press A, press A, and that's it. Nice. Go back to pseudocode, and you can see something like this. Okay. what you can see here, we successfully defined the string compare, but we could also do the same for example, this function string assign, which will basically just we can see what it does. String assign in system, copy, and just find it. It's again in system, find and check it. String assign destination and string. Okay. Yes. String. So we can again, you can see the result is basically v7 and v7 result. So it's the destination string, just is the return value. So again, retype it. We can do it again like wait. And here is again destination string. This the string. And the second argument should be source string. What we'll do, what this function do or does, it basically just assign or copy the content of the source string to destination string. Second argument, source, destination. Okay. Here we can rename it as a string 2. We can rename it as a string 3. And yeah, nice. You can also see that it's a Fastcall convention as we defined for Delphi. Again, Fastcall, nice. Here we have also some other things like a string to integer, which is in sysutils. You can see that it thinks that the first argument is integer, which is not correct. You can just copy that, copy, and again find here with in sysutils, or you can find it like if you scroll up, you can see here is the function. If you check the prototype, view prototype, you can see it's a string to integer, which grabs the argument as a string, and return value is integer. Okay, just Y. Oh, sorry. I press Y, and return value is integer, which is correct, and the argument should be okay. Nice. Just go back, press F5, and that's better. Now we have here the things which are related to Delphi should be quite nicely retyped already. I think maybe there is something I missed, but system param string. You can see that yep, it now already know that it just takes 2 arguments. So like this, better. We can find again the prototype of the function in interactive Delphi reconstructor, and okay, here it is. But you can again jump to system and here find Control F, and you can see here get param string. Here param string index integer It's string. Okay, is it correct? View prototype. One argument and return is string. So just go back and we can change the prototype. So return is string and it goes here the integer. It's quite strange. Okay, we will make it as it said. Index and string is return value. Okay. No. Index. Nice. And return is some kind of result. Or here something. And result is processing the command line. Okay. Yep. So first of all, we can see, we can start to analyze it. We'll maybe later find some things which has to be retyped too, but we can just start. So we can start from the beginning, and what it is here, just you can see. I will show you also the disassembly view, synchronized with pseudocode, and here it is. You can see that IDA quite helped us very nicely, that it treated as a mem copy these assembly instructions, which is nice. And what you can see here is basically a copy. This one should be source, and you can see the source is the infected MBR. So this should be the new MBR, new MBR score, because the program will be working with the copy in here. Nice. These are some values. You can see the 2f, which will be converted to integer. So you can let us do something like integer 2f. Integer 0, 0. And again, integer 0, 0. As you can see here, it just converted 0 to integer. What we got next, you can see here that it just tries here, if this is not true, false, false is true, so we can check what this function is doing. Okay, but it will return something, and the return something is from here. Yeah, so it will probably check if our current token is associated with something, with some okay, we will check it. But the important thing is basically that you can see that the return value from this function, allocate and initialize sit, is bool kind of bool, and it goes to result, and the result goes to here. So it should be bool. Let's change it and to bool. Okay, check it, better, and just rename it. We just have to identify these things. So first of all, let's try to Microsoft documentation. Check it here, and where you can find that the first argument is some kind of PS ID psit identifier authority, and you can see the sit identifier authority has some values, and the values are here. And if you check our value, first one, you can see it's 5. Nice. So 5 should be security anti-authority. Just go here and rename it. Okay. What are the next arguments? You can check the arguments here. The second argument is sub-authority count, which is correct because you can see 2 sub-authorities, and this is the first one, this is the second one. This is correct. But what is this? Sub-authorities. You can see the sub-authorities is sub-authority value to place in sit. Okay, but what we can see here, well-known sit. Okay, because this is some kind of sit, so let's check it. It's 32 in decimal and 544 or 212, 220 in hexadecimal. So let's jump to well-known sits, because this should be some kind of well-known sit. You can see the result is basically sit. Yep, so pointer to sit. You can see some well-known sits. Okay, we can try to see, for example, oh, I missed it probably. You can see it already here. That well-known sit is, for example, here, domain alias read admins, ending 220, and it just has the value of 1, 5, 32, 544. So just copy that and try to find it in IDA. If you mark this and press M to apply enums. Enums are basically something like a string name for some number, decimal or number constants. These are basically enums. Let's find it somewhere here. You can see it here. Nice. You can see that the defined types are basically, the defined enums are in the type libraries of MSSDK and also in Borland Delphi, which we already loaded in type libraries. Okay, nice. And the 32 value is basically somewhere here. 32, you can see security built-in domain rate. Copy, and maybe we can find it again in IDA. Yes. Enums, Control F, find, and find this one. Yes, it's here. Okay, I don't like this kind of output, so you can change it in the the Hexrace plugin options. Just go to plugins and Hexrace decompiler options and change the margin to, for example, 160. Okay, and it's better. So you can see basically that this will create the sit for domain local domain admin. For admin, it will create the sit here, and this one function will just check if current thread, because the first argument is 0, is has token associated with this sit, and this one should be some bool if is member. Yep, so rename it is member. Nice. You can check the function also in Microsoft documentation again. And if you check it, you can see that if the first argument somewhere here, token handle blah 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 blah, if the token handle is null, check token uses the impersonation token of the calling thread. Yep, so the calling thread token. And if it's a current token of the calling thread is a member of this kind of sit. So basically what it does, it just check if the current process is running as elevated as admin. Nice. So we can rename it like is run as admin. Okay, better. If it's not running as admin, it will just perform these things. So it just find window shell tray wind. This is basically name of window of some well-known process. So we can find it, but I will show you very fastly that it's a explorer. It's a taskbar basically. If you check the explorer here, go to Windows and check it here. Here you can see the window, which is called Shell Tray Wind. Nice. So it will try to find this window, the Explorer, the taskbar. You can check it like this, taskbar. Find window, and you can see the class name. Sorry, it's not a window name, but class name. And you can see that it will post some message. And what is the message? So we can see that it's a message ID. We can try to Google it. It will be faster. So we can do something like this. And Windows message, this one. And you can see that it's a VM command. VM command, WM command. Nice. So let's try to press M, and as we already loaded the types and enums from the Windows, try to find, sorry, VM, you can see it here, VM command. Nice. And now we have to find out what are the flags or parameters, W param. Okay. We can find it like message VM command and this value. So message VM command and this value. Sorry, like this. Here is something already in Stack Overflow. It could be quite useful. We will see. We can try to find the constant. And we can see it here. One way is to get the taskbar handle and send it message to hide all windows. Perhaps something like this, which has worked for me on Windows 7. Is this. You can see that it will just try it again. Shell tray window and VM command and minimize all. So this is just minimize all. It will just send message to a taskbar, basically to to hide or to minimize all windows. Nice. We can try to find enums for that, but it's not here. It's not here. So we can define it ourselves. Go to enums, right click, add enum, window stuff. Okay, and add here new one. And it will be name like minimize all, and the value is this one. Okay, now the enum is defined. Just go back and press M and it will be here. Better. Post message. So this will just hide or minimize all windows. Again, check if running. Again, if it's not running as the administrator, it will just do this one. Index. Okay. Get command line. It will just do something if the index is null, which is this case. The index is null. It will do this one. Get command line. The command line is here. Okay. and while one something command line. This one is doing something. It will try maybe parse the command line. Not important. But here is something which is quite interesting. 3 arguments. You can see it was wrongly recognized before. Here better. And what it is? This just, if it's not running as administrator, it will just spawn it, elevate it. You can see run as, shall execute, run as. Shall execute, run as. First one is what? Handle window. Okay. This one is what? V2, V10, file, file name. So A2 should be file name or module name. Okay, and A3, argument 3 is what? If not, something, something, something. So this is some kind of bool value. It's 0, 0. So this is false. False. We can retype it. Maybe like this. And this one could be bool. Okay. Correct. But maybe this one takes 2 arguments. I don't know why it's not recognized correctly. We change it, but if you check here, maybe this signature are not recognized correctly. Param string, because there are 2, param string and get param string. Maybe we could change it to 2 arguments. I don't know. Yep, and you can see it here. So again, what is the result? Result is return value is this one, and this one should be something, probably module name, because you can see it here. It's the command line maybe, and the command line argument here, first one. The second argument is module name, because it goes here and it will be invoked here. Point file. So let's change it to file module name path. Okay, and this is basically what it does. Shall execute run as. Shall execute run as. No cute, but shall execute run as. Okay. Correct. So we have this spawn as, spawn run as. Now, so this will be performing the loop, and I already know it's some kind of strange, but this is basically bug here, or something which was not used as the intentional purpose, because it will try to minimize all window, but this should be in this loop. I will show you later why, because whenever you will you have defaultly enabled UAC on your PC or on a computer, and whenever you will try to spawn something like run as to run elevated, the UAC will just basically throw up and it will hide all your window, and you will have to click yes or no. But here is the loop, so if you click no, it will just perform it again, and you can't do anything. But if they're in this loop, you can basically press Ctrl Alt Delete and run the class manager and kill it. But if this would be in this loop, you can't see the task manager because it will be immediately minimized. So this is probably some kind of bug. What is here is basically reading. You can see here is the file, or here is the handle file. Oh, sorry. Rename it handle file. Copy because there are more. First one, here is the create file. Where are the create file? Create file here. Here is the second one. No. Handle file. Yes. Just copy this and create file. Another one. Handle file. Yes. And here is the other one. And I will tell you why there are too many create files. And that's it. What do we have now here? First of all, here is some function. Okay, create file. It will just basically open handle to our drive, and here is something. So we can just Google create file A because the constants I can't remember. Create file A. I know that this should be some kind of open existing and share mode, probably read write, and something like here desired access. So first of all, let's check it here, and first argument is desired, second argument is desired access. The desired access is some kind of mask, generic write, just show me generic access rights, and you can see generic all, execute, read, write. So we can try to find generic in enums. Just press M again, yes, Ctrl F, and generic. And you can see generic all, nice. So generic all, and you can see it's everywhere. Generic all, and generic all. What is the third argument? Is a desired access, or no, share mode. So share mode is here. Share mode, and you can see the share mode is here. Like it's ORT, yeah. So it's operation like a file share read or file share write, and it will create the value of free. You can see it here, the free. So it's basically a read, file share write, and you don't have the ORT like values in enums, so we have to define it ourselves. So copy that and just create enum for that. At enum it will be share. Okay, it doesn't matter. And create new one. File share read, right? And the value is free. Nice. Just go back and press M. File share read write. Okay, we can do it for others too, because it's the same everywhere. And what is this one argument is basically security attribute, and this one argument is creation disposition. I think that it should be open existing, but we can make it sure. Sorry. and the fourth argument is somewhere here. Creation, disposition, and you can see the free is open existing. Nice. So let's change it. Press M, because for this should be defined enum. Press here new and try to find open existing. You can see it here, open existing. Nice. Let's change it to everything, every call of create file. Open existing, and open existing. Nice, that looks better. Okay. Maybe we can try to reanalyze our program. Oh, sorry, here, reanalyze. And now press F5. Yep, something changed. Here it's treated as strings, or renamed, string free to blah blah blah, something like this. Okay. I don't know if we could treat it as a string somehow, because it's in code section. We can try to do it in plugins and hexarray compiler options and analysis option, and print only constant string literals. This basically means you can hover over it and only print string literals if they reside in read-only segments, but it's in code. So if we can uncheck it, it could print for us the strings, but I don't think so, because it's as a Delphi. Oh, we have the nodes here. It's better because you can they are also defined in the, sorry, but this is not treated as strings, but it doesn't matter, it's okay. So let's come back, and what you can see here, just to grab view, another thing is it will just basically okay, open the our drive and handle, and it will just read 512 bytes. So this is our original MBR. So this should be the buffer, I think. Yeah, buffer. And this is basically we can treat it as file buffer, because it's used in more functions. So press N, and we can so red buffer. Okay, and you can see that this buffer just goes to this function, and what this function is doing is quite nice and interesting. It's not recognized. I think it's some kind of Delphi things, but I don't know, I'm not sure about it. But you can immediately see that it's referencing something here, and you can see that it's a hexadecimal alphabet. So why hexadecimal alphabet? My first assumption is that basically here goes bytes. Yep, bytes. And this should be something, because you can see that it just try to this, goes to this. Again, new MBR, the infected one, goes to the same function, this, and this is string compare. So basically these two things should be strings. So this function is some kind of responsible to convert the bytes buffer to some kind of strings. And as already here is the referencing the hexadecimal alphabet, it should be bytes to hex strings. Yeah, this function. We can already rename it like bytes to hex string. Okay. And we make it sure, because you can see that it's here is probably what is the output result. Yeah, the output is not treated here, it doesn't matter, but this should be the first argument. You can see already that it basically set length, and the length is basically this one. So this should be the length of the bytes, probably. Yes, you can see it here. So this should be the length. This should be a new another length. Yes. Set length. So it will set the length of probably, yeah, the A3. Yes, you can see that it will set the length to a double time or 2 times of the original length, which is basically correct, because if you have 500, for example, 12 bytes, you have to have 124 string values. Yeah. So if you have, for example, byte FF, you it's like 1, but the hex string is basically 2 in length, because you have F 1 character and F second character. So this should be a correct assumption. It will just convert it to hexadecimal strings. So this should be the hex string. So the third one should be something like or we can retype it and we can change it to string. Okay, and what you can see here is another length. Yes, v7 is some kind of counter. You can change it to I, it will be better. A1 is what? A1 is the original, is the bytes. These are the bytes. Bytes 2 convert. Nice. Here will be the same. Yes. And okay, that's quite I think it's quite obvious that this will basically perform the conversion from bytes to hex string. So this one should be this one is, you can see the first one just reading the original MBR. So this one should be original MBR hex string. And yep, this is the same. So we can just do it like this, underscore okay, and here rename and like this. Yep. And here it just calls it again, but now it converts the infected one MBR to another hex string. So we can rename it again, but this one will be a new MBR. And string compare. So it's quite obvious what this function is doing. It just makes sure that the MBR on this system is not already overwritten, and if yes, because yeah, be careful, because you can see here the value may not be maybe undefined. It's correct because it's not some kind of variable. It's a zero flag. Yeah, it's a zero flag. You can see here that it's just called string compare, and if zero flag, yep, it jumps and other things, blah blah blah. So basically, this is we can rename it as a zero flag. Zero flag. Nice. So this one, if not, takže sorry. If drive not already overwritten, If dry is not already overwritten, it will just do this. And if yes, it will just finish execution. Nice. So this is just check if it's already overwritten. What do we got next? Next, you can see that it just closed the handle handle to the drive. It will create the handle again, because whenever you read something and with the handle, it will just move the file pointer and other things, and it will try to start from the beginning again. You can see it here. So first of all, this one just reading the drive first 512 bytes to this one, and set file pointer and write file to this. Okay, so this one is just reading original MBR. This will set the file pointer to offset 512, and after that, to this offset, it's something written. The written is the original, so this is some kind of backupping of the original MBR. So let's backup original MBR 512 to 1023. This will be the raw offset of the backup original MBR. Now it closed the handle, and again open the handle to the drive and write here the new MBR. So this is just overwrite, or we can just do inject infected MBR. Close handle. Again, it will just create handle to drive from the offset of 0. Here are some nodes which are basically copied. You can see source to destination. So these are some new nodes. And this is the size, I think, yep. And what you can see, it set the file pointer to offset 1024. So basically, the backup of original MBR is 512 to 1023, and this is basically the file pointer is now on 1024 in raw offset on this drive. And now it will basically write the random nodes, or no random nodes, but the noob nodes. So write noob nodes. Okay. 1024 to, that's okay. Yep. Correct. So after this, I'm quite sure that first 512 bytes, which is MBR, will be the infected MBR with the infected Bootstrap code. The offset 512 to 1023 will be original, the backup MBR, and offset 124 to 1024 to something will be the noob nodes. And what is this? This is some checks, and if these checks, this is some assignment of the string, and you can see here are some checks. Basically, these strings are equal to free_n string, free_n. You can see it here, free_n. So basically, free_n is compared to 1n, which is false. So basically, this one is false. Free_n again is compared to string 2n, and this is again false. And this one is just this one is true because it's comparing free_n to free_n string, and this one is true but it just do nothing. Nice. Here are two functions which will not be executed. Yeah, not executed. Again, not executed. What this function does, basically it could be quite interesting to check what this function is doing or other things. So we can see, yep, IDA firstly thought it just grabbed some argument, but it not, so it's better here now. So let's check it, and you can see immediately here is just setDebug privilege, so this will be some adjust token privilege. You can see the argument first one is setDebug privilege here, so this should be again string, but I won't be retyping it. But we can see that adjust token privilege, here is the string goes here, the string goes here, and the string is lookup privilege, and it just goes here. Yep, lookup privilege, and the privilege is new state, and adjust token privilege. So it just set it back. Adjust set debug. Debug. Nice. What is this? It will set our process to critical, probably. Set process and to critical. And because, yep, it just doesn't do anything more, but you can see here one function which is called 3x, and these are basically names of some processes, window processes, which are critical. So I think already that it will just try to terminate them. Basically, it will be in the state where the original MBR is already overwritten with the infected one, and it will probably try to force the system to reboot. Yeah, so you can see open process and terminate process immediately. So if you follow this one, A1 goes to V20, and it will be just converted to uppercase, and here is V18. Okay, this is some kind of strange, but I won't be dealing with that. This should be terminate critical process or terminate process. And we can rename this function. What it does, basically adjust set debug and kill critical proc. Okay, and here is our function, which could be quite interesting too, and you can see that it will just basically do the same, but in a different kind of method. First of all, here is some check, and with value 2, we can try to figure out from where this one, it's offset. So it's offset, you can see basically this is just used here, okay, but if you check it here, what is this? References, and you can see that here is the writing, and it's platform ID from get version. Nice. So copy that, and we can rename it platform ID, a major version, and minor version. Or no, sorry, minor version. Nice. So platform ID So again, we can change it to this. If platform ID is 2, okay. Maybe we can check the function where it is, it just from the function get version X. Check the Microsoft documentation. And you can see it's version information. And maybe here the version, and we can try to this one, and you can see the platform ID, and the platform ID could be 2. Yeah, only possible value. So let's check it, and we can apply enum again. So let's check, press M, okay, new, and try to find this one, and you can see, yep, here. So if the platform ID is this one, it will just open get current process, open process with some access. I don't know if we check it, but it could be again probably, or we are not interested in that. But we can see that it's just basically look up the privilege, say shutdown privilege, to possible shut down the PC, and adjust token privilege. It will adjust the privilege, the session down privilege, and it will try to exit Windows X. And exit Windows X is a function which just takes the flags. The flags are set when the function is called. It's 6. And what is 6 in flags? And also reason. So let's check again Microsoft documentation, and here Microsoft documentation, what it just tell us about it. You can see the flags, and flags are if we have the value 6, and you can see it could be a combination of this. So 2 is EWX reboot, and 4 is force. Nice. So basically this is a combination of this reboot and force. Reboot and force. Nice. We could again define an enum because it just ORT value again. So this there will be no enum defined for ORT values of enums. So let's add enum. We can do like flags shut down. Okay, and just add here a new enum member, and it should be reboot force, and the value is 6. Okay, just go here, and we can apply the enum here better. Nice. And what is this? The reason is here, the 0. Okay, reason should be somewhere here. Oh, reason. The reason system shutdown reason codes, and we can see that the 0 is something like, yep, here shutdown reason major other. Okay, other reason. Press M, and new one. Control F, find, and yeah, it's here. Nice. So this will just what it does, basically adjust say shutdown exit, or no, reboot system. Nice. And what we have here, we have probably everything. Yep, and it's already, we can save the database, and it's already all is quite clear, and we can understand everything what is going on here. First of all, we can try to make some notes, or yep, notes. So first of all, what it does is basically checking if it's running as admin. If not, it will minimize all window. So if not admin, minimize all windows. If not admin, shell execute run as. What's next? You can see the next is yep, shell execute run as, and in loop. Okay. First of all, it will just compare if the drive is not already overwritten. Is drive already infected? If yes, exit. If no, continue. What it does here, backupping of the reading original file, backup original MBR. So backup original MBR in offset 512 to 1023. The inject infected MBR. Okay, so overwrite write MBR with a new MBR infect, and it will be done in offset 0 to 511. And the last one is basically just writing nodes to offset starting in offset 124. Write nodes to drive, and it's starting in offset 1024, and it goes to, I don't know what is this size, 3072, but it's not the size of the nodes. The rest will be probably nulls. Okay, doesn't matter. Yep. So like this. After that, it performs some check which will not be executed. You can see it here. It's not executed. We will make it sure. I will show you. Okay. Not executed functions, and this one are basically the kill critical process, which will basically result to blue screen. Blue screen reboot, and another one is shutdown privilege and exit Windows. Nice. Okay, we have everything. And we can make it sure. How does it work? Also, you can see that basically we can grab the new MBR, the infected one, from here, 512 bytes, but we can also let the malware infect our system and grab from the drive. I will show you. So here is the executable, and if I set the UAC user account control, the default value I think is this one. Okay, and I will show you the loop one. It's quite funny. But as I already told you that this is wrong, the minimization of the window, because it should be in the loop. And if it would be in the loop, it will just work correctly, and it will minimize, for example, task manager, so I wouldn't be able to kill the process. So it works basically just like this. Now if I run it, it will just hide the screen with user account control. If you click no, loop, here is the loop. You can't do anything, or just press close, no. So this is the loop, and you can see that all windows are minimized. Yeah, but there will the other windows which will be created wouldn't be minimized at all. So it's this is the bug. I think the creator tried to miss the purpose. So we can just insert an input control Alt delete to our VM. Yep, and we can just start the task manager. And it's there. We can just again control Alt delete and go, okay, go to details. Okay, again control Alt delete. I will just show you how you can basically terminate the process. This is the bug of the actor. So again, cancel, sort it by name. Again, cancel, try to find the sample, it's here. Okay, again, we have it here, again, fuck, again, and process, cancel, and we terminate the process. So basically, the creator or the developer of this malware just missed the purpose. If the minimization of the all windows, these functions will be in the loop, I wouldn't be able to terminate the process via the task manager. But it's just detail. Okay, so we didn't infected our drive yet. Yep, because we just terminate the process. So we can terminate it now, and I will just show you that our assumptions are correct. So what we can do? Run as administrator. Yes, because I want to read the drive, the original drive. File, open drive, and open the physical drive. No, and you can see this is the original master boot record of my drive. We can just copy something. This should be enough. Copy to this one, hex, and yes, that's correct. Now you can close this. This is the original MBR, and we can run it elevated. Yes, and it should be done. Already infected. You can see no reboot, no killing of critical process, because this condition are not wouldn't be met. So basically we can see that already the drive is infected with the infected MBR. So again, open drive, open it and check it here. This is the original one, and this is the infected, and you can see it's already overwritten. Yep, you can see this is the basically bootstrap code of the infected MBR, And you can see here that we were correct, that this is basically our backup MBR, absolutely the same as our original. Nice. So first 512 bytes is the 512 bytes is new MBR, the infected. The backup original MBR is 512 to 1023. You can see it here. Original backup. And from the 124, the shitty noob nodes here, which is here. Write node to drive. So we were correct, absolutely correct. And what we can do now, we can basically copy these stuffs, and we will create a Bochs image from that and analyze it. So we can do it like this. Just copy this. For example, here, that's enough. Copy, replace this. And this should be correct. Yep. Yes, and 4000 should start the nodes. Yep. So just save it. We can close this drive and save this as save as desktop, and this will be the infected drive. Save it. Nice. Now it's time to just grab. We don't need this anymore. We just know everything what is going on with the infector, with this kind of malware. But we need to investigate the actual or infected master boot record, Bootstrap code, which is injected basically, and the code is here. Oh, sorry, it just copied. Here is the code. But this is basically already injected to our drive. So my VM is already infected. We can close it back. Okay. So this database is already prepared for you, or similar database is already prepared for you here on the GitHub. So you can download it, you can cheat a little bit and see what is going on there and try to do it on your own. So let's, we have the infected drive here. We don't need the nodes anymore. And what we can do is basically, we will need the Bochs image. We will try to create a Bochs image of with the infected master boot record. So you have to find the Bochs emulator. It should be installed in this location, and it's here. Yeah. So let's create a Bochs image. We will do it quite simply. Bx image. Okay, create new one. Create HD. Create flat. Create sector size is 512, the same as we have, and 10 megabytes is the smallest size, and it will be the infected drive. Okay, nice. Now we have it here, somewhere here. Yep, here it is. So let's just copy the path and open it in hex editor, because we need to replace, sorry, what is going on? Replace the content of the Bochs image with our infected drive. So let's file, open, go to the location, yep, and oh, sorry, go to the location and infected drive, open. Okay, and I would like to open also the one I saved, the copy of our infected drive I saved on the desktop here, and just copy this to the Bochs image. So first, for example, 7000, it should be enough. Like this. Copy that. Go here and just paste it here. Like this. Nice. Save it, and this should work. We have it here nicely. Yeah, first 512 are here. This is just the boot signature is here. This is our backup, which ends 400. Yep, here. And this is the new nodes. Okay, we have everything. Save it. Okay, we can close it, and the image is prepared. But we need to prepare the Bochs configuration file for this kind of image. You can see that it prints you here. The following line should appear in the Bochs source configuration file. I already prepared nice guide how you can basically do these things on my GitHub page. So if you just try to find Bochs GitHub damn guy, it should find this one post on my GitHub, and it's basically guide how you can do this with Bochs and other things. And I already prepared things like this. How you can create a Bochs image, and now just create a Bochs configuration file. So here, copy that, go to here, create this one, yes, and just copy here the configuration file. This should be okay, but we can modify some things because I already found it that some configuration is not optimal. So we can change the CPU, and we can change the boot to only boot from disk because it's correct. And you can see the name is not this one, but the name is, I think, called infected drive. Infected drive. Infected drive. Save it, and it should be correct. And check that ROM image is BIOS Bochs latest, which is here. Yeah, and the same is for VGA ROM image. And so basically the script should be in this location where these images are located, or you have to copy these images to some different location because it's needed. Yep, so that's all. Now you can close this, and you need to run this as an administrator, the IDAPro, because the IDA database should be in the same location too, and we need to load the Bochs configuration file to image. I will show you. So run as administrator, yes. Okay, and what we can do is basically create a new and find here all files and just try to find the Bochs source, which is this one. Okay, yep, and it's here. And you can see what is done. It's basically if you just try to print line prefixes, Okay, and we can try to go to text view. You can see that you are starting on the location of 7COO, which is virtual address where Bootstrap code of master boot record will be written in RAM during the boot process. So this is basically hard-coded, some kind of hard-coded virtual offset, virtual address where the master boot record will be loaded every time. So you can unidefine this one and change it to ASCII. You can see the Wabi chip tag, the builder, and here is the code, Bootstrap code. But this code is not recognized here, so we can make the code from this. Yes, okay, and we can also create a function to better view that, because now you are here. This is the function. This starts here and ends here, but basically it will just return to this instruction, and we can't see that as a graph view because it's not a function, it's not a recognized some kind of blocks. So we can just mark this, and here is the end, and we can convert it to function. Go to edit, we have the selection function and create function. Yep, and that's it. Now you can go to graph view and check this. It's far better than the text view, because you can see here immediately some loops, and you can see another loop here. Here is here. Nice. We can go back. Nice. Go to text view because we want to see more. What is, yeah, you can see that it's not loaded here. The rest, like the nodes, noob nodes, and the backup of our original master boot record, but it doesn't matter. It will be loaded because the IDA and the Bochs source will be working with this one. We can close this. It will be the program, and any kind of drives operations and modification will be working with this infected drive image. So we can later see what is going on with this one. You can see that if we check that, this is now the state of the infected image. This is also the state of our virtual machine image, a virtual machine, yeah, because we already infect ourselves. Nice. We can start to debug or emulate the image with Bochs debugger. Just press here the breakpoint and run it. Yep, everything is going well. Low desktop, default desktop, and here it is. We are on the start, so we can continue. And you can see here is basically some reading of sectors to memory. It's done, and what is here is basically returning to the code we already defined here. Yep, it's not recognized as a function, but we can help this. Edit and functions, create function, and go to graph view and better. So we are now on the start of this routine here, and what is going on here, you can see that it's working with with some kind of video syscalls or BIOS calls, and you can see it basically this just set where the scroll bar is and where the pointer of the scroll is and other things. But this will just print the, you can see right character and advanced cursor, so it will just basically write some character and the cursor will be moved to the next point of character and everything. So we can make it sure just continue or no, step, and here is the loop. First one loop, it will just compare if all the noob nodes are already written. You can see here, first character was written, you can see it here. Yeah, this was just also changing the color to green and everything, so not important. But this you can see here that it's writing to the screen the characters from the nodes, noob nodes. Okay, so we are not interested in this anymore. We can jump here. Just press put a breakpoint and continue. Yep, we are here, and all nodes should be written here. Nice. Uh, you can see here some code. You can see here system wait. So this will just wait for some time. And here is the read character from buffer. So this will just read character from buffer, compare it to some value, and if something was pressed, some character, it will check also some shift status. So if another like another some keyboards are pressed, and if all is met, all conditions if all conditions met, it will just read sectors in memory and write sectors in memory. And what it does, you can basically see somewhere here is basically read sectors, and you can see the sector count is AL, number of sector is 1. And you can also see the address somewhere. What it basically do, it will just read the backup MBR, yeah, and write it to the infected MBR. So it will overwrite all the things which were written to the drive, the infected things, and it will override it with the backup original MBR. So this is quite interesting. So this is some kind of hidden kill switch. So basically it will recreate our original MBR from the infected drive. Nice. So we can just continue, but we need to figure out what key press, like what keys should be pressed in what combination. First of all, you can see here is some wait, and here is the check. So int 16, and after that the HR is compared, it's a scan code is compared to 1. So we can find in 16, and you can see the AH before the in 16 is 0. So we can try to Google for something like BIOS in the 16 HI AH 00 scan codes. You can see that in 16 AH00 is read key press. So IDA helped this quite easily figure out. So we can continue. Read character from buffer, which is correct. But we need to figure out the scan codes somewhere. Okay, we will need this one later probably, because we can see that beyond BIOS scan code, so we can maybe try to Google this one, BIOS scan code. BIOS scan code, this looks quite interesting, and you can see that it's compared to a value of a 1. So what is 1? 1 is escape, so it should be escape. Okay, so compare if pressed escape. Okay, no. Compare if escape pressed. Yep. And we can also create a command here, like here, and is escaped is assets esc pressed. And here is our things. If the escape is not pressed, it just goes back to the loop and again wait and read character from buffer, check the scan code, and again. So if we press the escape, it will meet the condition and it will just go to this block, and this block is just checking get shift codes. It will just get the shift codes and it will compare this value. You can see it's ending with OF, with F value, and it's just compare if the C. So it just needs to be a value of C, which is 12. Okay, keyboard shift status, which is basically interrupt 16 in INT 16, and you can see the AH2. If we check it here, we can go back. Int 16 AH2 is get shift flags, it's correct. And we can see here is the bit fields for keyboard shift flags. Nice, it's correct. And you can see that it's checking what bits were set. And you can see the bits values is C. It's checking if C is basically pressed. The set bits has to be 12. So what is equal to 12? You can see these are 8 bits. 8 bits. So you can imagine what is the what bits should be pressed to be equal to a number of 12. First is this is basically two this value is basically 1, this is 2, 3 is okay. I will make it clear. You can see basically something like this. If we just jump to the cyber chef, it will be very easy. Okay, and we can convert to binary. And we need to, okay, I will do it in calculator. We need to convert 12 to binary, which is 1100. Correct. And this is basically, if you check it here, this is the 0 bit, first bit, second bit, third bit. So second and third has to be pressed. Yep. To basically create shift flags of value 12. So 2 and 3, the second and third, is Control Alt. Control Alt has to be pressed. Nice. So we know that this one is checking if Control Alt is pressed. Compare. No. Is Control Alt press? And we can again make the command here. Edit commands, and here. Okay, nice. If it's pressed, it will just edit commands here. It will just restore original backup MBR. You can calculate on your own these offsets, reading sectors. Basically, it will just read the original MBR and override the original with the original. It will override the infected drive. So all will be deleted, like all the nodes, all the infected one, and blah, other things. So this is correct. So how we can check it? For example, we can check it here. We can put a breakpoint here. We can delete the breakpoint from this, and this should be a loop, which will basically wait and checked the key press. So if we press the escape, we should end here. Escape character. Okay. But we will not press the Ctrl Alt yet. So we are here. We can continue. Yep, you can see it's running. And it's not stopping anywhere because it's in this loop. It's just wait, check the escape key pressed, and it's not pressed, it will continue. So now it's time to press escape. And we hit the breakpoint here. Nice. We hit the breakpoint, but you can see that basically we didn't press Ctrl Alt. So we are continuing again to this loop. So we can delete this breakpoint and put the breakpoint here. So when we press the escape and Ctrl Alt, it should jump here. So let's run it. Okay. And now I'm pressing the escape, and it will not be jumping here because no Ctrl Alt is pressed. Escape, and now Ctrl Alt. Oh, sorry for that. Okay. Yep, we are here. We are here. That was fun. Okay, we can see that I successfully pressed it correctly, and we can see Ctrl Alt Escape is the hidden key combination to restore our things back. So we can do it, read sectors to memory, and okay. We can continue write sectors again, okay, and it will end things. Okay, we can stop it. We can stop it. It should be okay. Stop it. And what we got here, if we check this image again, it should be the original one. Yep, you can see the original MBR is restored, and all the rest things are deleted. So all our assumptions are correct, and it's all done. Nice. But don't forget, we also infect our drive. So if you check it, open drive. Okay, I can't do it because I'm not running as administrator. But if I check it here, open the drive. Open the drive. Here is one, and you can see that it's still infected. So we need to reboot it. Okay. Oh, I can actually use the IDA for that, as I already told you. Oh no, because it's already overwritten. So I will just close this back. Okay, close this. No. And reboot it. Restart, and you will see the same what we did with the Bochs emulator, with the IDAPro. Safely, we didn't have to infect our VM. Just I did it because I want to show you also the drive structure and other things. So now our secret hidden key combination, Control Alt Escape, and wow, we are booting our Windows, and all is already backed and the restored, and the infected things are gone. So we can check it again with hex editor that our drive is the same as it was original. Come on. Yes, and now hex editor, run as administrator, check the open drive, this one, check it, ignore, check it, and you can see the original MBR is restored, and nothing more is here. And that's it. That's it. That was all of it. I hope you enjoyed it. I know it was quite long and exhaustive, but I think that it's quite necessary, and you can also use the FLIRT signature and the things I show you how you can deal with the Delphi compiled programs with all kind of situation, not only with this in this one, but whenever you are dealing with Delphi program, try to remember the interactive Delphi reconstructor, check the prototypes, use the IDA, you can redefine the types, and you can also change the compiler, change the calling convention, change the string literals, and apply the FLIRT signature, apply the types, Delphi types, and you will just get this kind of nice code, which is nice, readable, and you don't have to deal with the default Delphi functions, which are not interesting at all. It's not the code of the attacker, it's basically just using string to integer and other things, and this is something you should get. Yeah, this kind of code, this kind of nice looking code, it's everything is cleared. Okay, I hope you enjoyed it. I hope you will just grab the things from the GitHub and try it on your own. Thank you for watching, and see you next time.